weight on any planet is F sub g, and that is equal to big G m1 m2 over r squared. Okay. Now, if the dA is equal to that, that means 2 RA is equal to 1.5 times 2 RB, or the same ratio holds true. So the radius is 1.5 times, the radius of A is 1.5 times the radius of B. So all I'm going to do, this is equal to weight. So I'm just going to put big G m1 m2 over R A over, and this is mass of A, 2 is the person, big G mass of B m2 over RB. So I'm just going to create a ratio. This goes away, person goes away, and we get MA RB over MB RA. And we know the masses are the same for part A, so that goes away. And so then we get a ratio of 1 over 1.5, or if that's, what, 1.5 is 3/2, so that's 2/3. So the answer for this is 2/3. Now, if the densities are the same, and density is equal to mass over volume, that means the mass of A over the volume of A is equal to the mass of B over the volume of B. And we got to remember that volume is equal to 4/3 pi r cubed. So I'll go ahead and do this one in yellow. So we're going to get, let's see. So basically what we're looking for is we're looking for the mass of B in terms of A, so that we can go ahead and solve this. The radiuses are this, that doesn't change. So we'll still be able to use this same equation here. We just can't cancel out the masses there. We can cancel out M2, we can cancel out the G's. So we're still going to use, MARB over MBRA, which comes out to be MA over MB, like 2/3 of that. Okay, so we just need to find MB. So we can see that MB is going to be equal to MA times VA over VB. Oh, just kidding. That's not correct. It should be VB over VA. And VB, we only need 4/3 pi r cubed. So this is MA times 4/3 pi RB cubed over 4/3 pi RA cubed. So that cancels through there. So let's shift this up. So that goes away. So we get MB is equal to MA times RB cubed or RA cubed. And we know that RA is equal to 1.5 RB. So I can go ahead and plug this in and say RB cubed over 1.5 RB cubed. And 1.5 cubed is 3.375. So MB is equal to MA times 1 over 3.375, or MA is equal 3.375 MBs. So we can go back again to our recycled equation, which said MA over MB was like 2/3. So if I now plug in this, I get 3.375 MB times 2 over MB times 3. Cancel that. And we get an answer of 2.25. So the ratio of the weight on A to the weight on B is 2.25. So we see that if you take the mass, if you have a small planet with the same mass as a big planet, then like the ratio of weights is less. If you take the densities as equal, then the mass of the small planet will be much less than the mass of the big planet, and that's why it results in a ratio of 2.25.